Alright guys, welcome to the next section. Families of right triangles. Who's the weird uncle of the right triangle family? So let's stick around and find out, huh? Alright, so first we want to discuss what a Pythagorean triple is. A Pythagorean triple is a set of non-zero whole numbers, A, B, and C. Well, non-zero whole numbers are called the natural numbers, such that A squared plus B squared equals C squared. So no matter what, A, B, and C are going to be whole numbers, or excuse me, natural numbers, and there are not going to be any fractions involved. So some common Pythagorean triples that we'll see here. Take a look at this, and this is where this is important to notice. Each of the top parts of this are the classification groups, all right? And basically, those are the initial four we're going to talk about. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Those are the common triples that we see used. Now you'll notice as we move down the columns that we've got 6, 8, 10. Those are still in the ratio of 3, 4, 5, 9, 12, 15. And then we get down here to this count, this row, 3x, 4x, 5x, 5x, 12x, 13x, 8x, 15x, 17x, 7x, 24x, and 25x. And all of those are going to be the ratios that the common Pythagorean triples are in. So let's talk about the principle of the reduced triangle. What we want to try to do is to find what the relationships are between this. Now, in this problem here, you'll see I've got a fraction. So to get rid of the fraction, I want to double it. So I can still get a ratio by doubling or dividing by 2, let's say. I can divide by 2, we can double, we can, if we get fractions or decimal values. So in this case, if I double this, and I'll put this in a different color, 4 becomes 8, 7.5 becomes 15, and then x becomes a ratio of 17. Well, since we divided them in half to get the actual lengths, 17 divided by half, 1/2 is 8 1/2. And we can see that here. So we've got 2 times 4 equals 8, 2 times 7.5 equals 15, and 2 times x would equal 17. And then we can just go from there. So the methodology that we will use with the principle of the reduced triangle is to reduce the difficulty of the problem by multiplying or dividing the three lengths by the same number to attain a similar but simpler triangle in the same family. And then we want to solve for the missing side of this easier triangle. And then convert back to your original problem. Okay, so we can see that both 77 and 55 have common factor of 11. So we can divide 11 out here. So that's what I'm going to do. I'm going to turn this into a 5 and this into a 7. So x divided by 11 is what we're going to end up with working with, right? So we'll call that y, all right? So now we're just going to use the Pythagorean theorem as our right angle and to solve. So y squared plus 5 squared equals 7 squared. So now I would end up with y squared plus 25 equals 49. Subtract 25 from each side. Y squared equals 24. We are going to take the square root of each side, and we end up with y is equal to the square root of 4 times the square root of 6, or 2 square root of 6. Now, because we divided by 11, so x divided by 11 is equal to y, we're looking for, so 11y, my crappy looking y there, is equal to x. So now I can multiply this answer here by 11 to get x. So we would end up with 22 square root of 6 is our final answer. So let's do some more example problems right now. Okay, so I can see that I can divide 10 and 24 by 2 and end up with this is 5, this is 12, so this is 13. So it's a 5, 12, 13 ratio. So since I divided by 2 to get the ratio, I'm going to now multiply it by 2 to get the side of AB. So AB would be equal to 26. Okay, this is a common problem where people just fall right into a trap because they don't look at things. This, if it's a 3, 4, 5 right triangle, 5 has to be the hypotenuse. In this problem, 4 is the hypotenuse. So we're going to end up with x squared plus 3 squared equals 4 squared. All right, you got to pay attention to that. So x squared plus 9 equals 16. X squared is equal to 7. Therefore, x is equal to the square root of 7. Okay, so here we have, we want to find the hypotenuse of this right triangle. If you get this situation here, this is nothing to panic about. It's just take the problem and write it out. 6 squared plus, keeping this in mind, and I put this in parentheses. Oh, wait a minute. This is a reduced triangle problem. What am I doing? So, well, what can we do to reduce this? So I can divide everything by 6 here. So this would be 1 divided by 6. This would be 3 square root of 3. All right, once we divide by 6. So this will be y, right? X over 6 would equal y. Therefore, x is equal to 6 times y. I just make this notation over here just to keep it, out there so I know what to do later. So 1 squared plus 3 times the square root of 3 squared equals y squared. Now, 3 square root of 3 squared. You want to keep this in mind. I'm going to write this here. 1 squared plus, we want to do this in this way. If I've got 3 in this, I'm going to square both of these. Okay, so that's why I'm doing that in a different the color there is equal to y squared. So now we can go ahead and simplify this. 1 squared is 1. 3 squared is 9. Times the square root of 3 squared is 3. 9 times 3 is 27. And that's equal to y squared. So y squared equals 28. Which now we're going to take the square root of each side. Square root of y squared is y. Square root of 28, that's equal to the square root of 4. The square root of 7. So this would be 2 square root of 7. Now we've got to convert back. So 6 times y is equal to x. We're looking for x. So x is just going to be 6 times 2, which is 12 square root of 7.
That's all, folks.
the home stretch here, guys. Let's finish strong.